painting. So it's got many kind of layers. And it changes.
Yeah.
That is more, I think it's sort of more how it is now. I will concentrate on a sound or a smell or a taste quite intensively in my studio, and then I will work out what the images are, what the colours are, what the textures are, and I will work out how to paint what is going on inside my head to create images like this.
We wanted to find a way to describe the colors I see with the musical notes in a way that wasn't very abstract, in a way that we could actually have someone meet me on the same level. So we created the synesthesia violin that plays that shows the colors that I see in real time.
And you had to name one of them Hoover and one of them Kiki. Someone else this one? Which one is this? A lot of our research is carried out with people with Merest synesthesia. So this is a particular type of synesthesia where if you see somebody being touched, for example, if I do this, you would start to feel touch on your own body. And it goes for all kinds of sensations. So if you saw somebody being hugged, you might feel like you're getting a hug as well. And what we know about people that have this condition is they also have high empathy. So we can use them as a model to study how empathy works in the brain and how we all understand what other people are going through.
And the diaphragm to contract and the lung to expand. And they do that with panic breathing. No.
Would you like to have a go on the stepper-tron? That's okay. The stepper-tron's really... So you've got the amygdala and the insulins, cingulate cortex. Drugs that make the lungs work better. Even if they do make the lungs work better, sometimes people remain symptomatic. And what we think is that there are differences in the way people perceive their sensations in their body that account for this variation. And we're trying to understand that through understanding the brain networks that generate these perceptions.
So, take your time. Ready, steady, go. Stop.
Well, the first thing we're trying to do is find out the pathways in the brain that are particularly relevant for breathlessness, and then secondly that we can direct new treatments towards that. And what we're really interested in is what are the computations that the brain is making to generate this experience, because it's only when you get right to the nuts and bolts that you can get a really targeted treatment.
The challenges are really maybe in the urban scenarios where you have unpredictable road users, many road users, bad conditions in terms of view, maybe congestion, and this is where we are not there yet, so that's really the future. But it's also creeping in. More and more cars have safety assistance with higher levels of autonomy, and at some point you won't even realize you will be sitting in an autonomous car and it will just feel normal. We need maybe larger bodies of groups of people, from policymakers, from researchers in social sciences, ethics, to come to a conclusion of what's really the best decision for the car. And then from the software side, we can just program it in, but somebody has to tell the software how it behaves ethically.
From about 50 Kelvin, so that was minus 220 degrees, to nearly Kelvin. So it's theoretically impossible because of various laws of thermodynamics to reach it. We're getting as